Hi, 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 hi. Hi, everyone. Welcome back. I think you are able to hear me first, and you must have watched the previous sessions where we discussed different PYQs from previous year questions from transmission and distribution companies, state electricity boards. Okay, Telangana state. So now we are here with Transco, TS Transco 2015. So let's see. Are you guys ready? Are you guys ready? Give it a thumbs up if you're ready. Then we'll move to the first question of this session. And these questions are easy. I guess you will be able to answer them quickly and accurately. Network analysis, I know previous questions we were collecting, and that's what I'm discussing in this. Next, which one you want, you can ask for it. We'll go for next in the next video. We'll go for maybe control systems or maybe power electronics or machines or anything. Okay, according to your choice. Let's go to the first question. Bang. First question is there, and the timer is also running for you. Within that time frame, you have to answer the question number one. Okay, yes, quick. I think within maybe 1 minute or maybe 30 seconds or so, you'll be able to answer this if you have that understanding already. Already we got some answers. Nice. Very good, very good, very good. Wow, good. So, Sudhir, let's give it up for Sudhir. He's saying answer as C. He answered first. Good. Next, Naveen. Nice. Manoj and Muhammad. Good. Keep it up, guys. Keep it up. Okay, I think I should stop this timer, right? Because it's 1 minute is, yeah, that's pretty much high time, for this question actually. What is the question? When the power transfer to the load is maximum, then the efficiency of the power transfer is. What is the efficiency? We know when, if it is a DC circuit, for DC circuit, if the source, we have some resistance and we have some resistance in the load. If the load resistance RL is equal to RS, then we'll have maximum power transfer to this load. This is true when load is changing. When load is changing, if you can make that load resistance equal to the source resistance, then power transfer to this load will be maximum. Power transfer is maximum. Means these two are equal means what? There is some voltage drop here, same voltage drop will appear across this. Means if it is consuming 10 watts of power, this will also consume 10 watts of power. So the bloody source is supplying how many watts? It is supplying 20 watts. Out of 20 watts, 10 watts is gone here. Remaining 10 watts are appearing across the load. Of course, that 10 watts is the highest value which it can have for the given circuit of RS. For this RS, excuse me, 10 watt is the highest possible value what we can get for a fixed value of voltage and any value of RL when RL is changing. But at that maximum power transfer condition, efficiency is 50%, means 50% of the power is lost. That is why we know at this condition we are going to achieve the maximum power, but we never operate that in a regular way. In normal usage, we don't try to operate at maximum power transfer condition because 50% of the power is lost. When you have some special applications where it requires that maximum power to happen, though efficiency is 50%, is okay, then what can be done? We'll go for it. Okay. Yeah. Hi Vinay. Hi. Let's Go to the next question. Are you guys ready for the next question? Bang. Next question is right there. We have a circuit diagram also. 2 minutes time. You answer this. And like the video, like the session. What are you doing? What are you waiting for? Thumbs up. There's the thunder. Good. Good. I'm hitting the likes here. I'm giving the likes for you. You also give the likes. Okay. So that it will spread to other people. That's it. Wow, we already got the answers. Vamsi has answered it as D. Manoj, Sudhir, Raviteja. Nice. Guys, keep it up. Nice. Mohammed. Easy electrical engineering Sai. Wow. Sudhir. He has answered it. Along with that, he has given explanation nicely. Right? Good. Okay. I think after looking at Sudhir's explanation, I should stop the timer. Okay. Because he has beautifully given the explanation also. So now let's dive into the solution without spending a lot of time on this. The source impedance ZS is 6 plus J8 in the circuit shown figure. Maximum real power transfer to the load impedance when ZL is equal to ZS conjugate, you'll get maximum power transferred, because if this is how much? 6 plus J8. Now if this is equal to 6 minus J8, then what will happen? This plus J8 and minus J8 both got cancelled directly. Okay, so we have no extra opposition offered by the inductance, only opposition offered by this will be there. Now we know when this resistance value is equal to this resistance value, then real power transfer will be maximum. That is it. We got it. Okay. And you try to recall the other conditions also. What if XL is 0? What if XS is 0? All of the conditions, you try to recall all those conditions. Good. Good, Sudhir. Let's move to the next question. Of course, answer is D for this. Okay. Moving to the next question. Try this. Let's see. Simple one, okay. This is not that difficult. But yeah, these are the previous year questions. What can be done? First, simple questions are asked. And then at that time, 2015. Now, I think SPDL questions, even then, SPDCL questions were really good. And PDCL, I loved them. Yeah, this is again a 1 minute question, okay. It's useless to take 2 minutes for this, but it's just a minute to win it. Okay. Okay, time's up. Let's see. Let's see what you got. I think it seems there is a glitch over here. Screen. Yeah. Milliman's theorem yields equivalent what? Milliman's theorem? Is it impedance or resistance? Most of the people are saying D. Yes, very good. Current source. In the previous video also I discussed about this. It is not just for a voltage source or a current source. We can use for voltage source as well as duality of that voltage source concept. If you do it, you will get current source thing. I discussed also that diagram with the help of diagram. So this, either it can be voltage source or maybe current source. Okay, good. So if it is a voltage source, You'll get voltage source and resistance in series. If it is a current source and resistance in parallel. Okay, shall we go to the next question? Give it a thumbs up. Good, guys, good. To every one of you, good. Keep it up. Okay, I'm moving to the next question now. On the screen, look at it, solve it. Okay, 2 minutes time, go. Good. Vamshi, great job done actually. Okay, good. He's answered within a minute. Beautiful. The concept here is very interesting. If you understand Thevenin's and Norton's properly, the power of Thevenin's and Norton's properly, how we got Norton's from the Thevenin's properly, then like the way Vamshi has answered, he will also answer it. Let's see. Try, attempt. I'm giving a hint, right? Hint is what? Thevenin's and Norton's combination of those. Okay. First find out. Whenever you got some circuits like this, what are the circuits you have? These circuits, whenever you have to apply the similar concept. Try to, normally students get stumble when you get questions like this. At that time, if you have more practice of these kind of questions, the block is there and we have some resistance. Then if you have good practice of those kind of questions, then things will be a lot more easier for you. Whenever you get these questions, you will get an idea how to approach. Idea is important. Let's see. Good. Sai. Good. Everyone. Let's now get to the solution. Now it's my time, your time's up. Okay. For the network shown in the figure, when I is equal to 0 and V is equal to 20 volts. I is equal to 0 means what? Open circuit or short circuit? Tell me. I is equal to 0 means open circuit or short circuit? Simple question. Yeah, come on. Quickly type it. I'm looking at it. Let's see who is going to answer first. This simple question. If you can't answer it, I is equal to 0 means open circuit or short circuit? I'm asking you. We got an answer. But the answer is not displayed here. Okay, Sai has finally answered, and okay, Vinay also answered it. Okay, others, what they're doing? Yes, good guys. That's it. A simple for me type OC. I'll be happy for that. Okay, yes, open circuit means open circuit voltage is given for the network. Open circuit voltage is given means open circuit voltage for the network is a Thevenin's voltage. So Thevenin voltage is given as 20 volt. This 20 volt is not just a voltage, it is a Thevenin voltage. Now when R is equal to 0, means open circuit or a short circuit or your circuit or my circuit. Which circuit is that? Tell me. R is equal to 0 means what? R is equal to 0 means what? R is equal to 0 means what's the state of that? Open circuit or short circuit? Yes, it is a short circuit. Means short circuit current is given, means Norton's current is given as 10 ampere. So Thevenin's resistance RTH is equal to Thevenin's voltage by Norton's current. This is a key thing. Of this entire thing. This is a key aspect. This formula. Okay. Yes. Clear? Now with this, at least now you do it. I'll be happy if you answer this now. Come on, please. Yeah. Others. I gave the hint now. Now you know the Thevenin's resistance. Okay. And you know the Thevenin's voltage, you know, Norton's current. You know now what is the, resistance you should use, 3 ohm resistance. So I think you know what to do for this, right? I'm blocking everything. Options also here. Okay, I'll go aside. This is question number. Question number is always getting displayed. You can comment if you're watching in the rebroadcast. Wow. So Thevenin's resistance is 2 ohms. 20 by 10, 2 ohms. So quickly draw the Thevenin circuit with 20 volt, 2 ohm and 3 ohms. So current flowing in this is 20 by 5, which is 4 ampere. 4 ampere. Here, it's not about the answer to this specific question. It is idea to approach whenever you get such kind of questions. Good to go to the next question. Whenever you get these kind of questions, think about just these two theorems. Which one should I apply? Should I go for Thevenin's? Should I go for Norton's? Or maybe superposition? Mostly Thevenin's and Norton's will give you the answer, but sometimes you'll have to go for superposition. Okay? And reciprocity. These theorems, you just focus on theorems whenever you get these kind of blocks. Okay, you have given these blocks are given. Then yeah, that's the only way. Okay? Let's go to the next question. Bang. That's a question for you. You try now. Let's see who will answer first correctly. Answering first is not a priority. Answering correctly is a priority. Then being quick is also a priority. Yes. A simple theoretical question. Just think about what is asked. Obviously, he's talking about maximum and average powers means AC circuits. Pure resistance AC circuit. Try to draw the voltage and its corresponding current. Then find out what is its average value, average power, and its maximum power. That is it. Simple. Don't commit mistake. Being hurry, don't do any mistake. Most of the students, I'm really not at all happy with this response is what you're given, because I think you're trying to react immediately. Don't react immediately. Think. Okay. Of course, it should have mentioned clearly. He's talking about AC circuits. Then things should have a lot more easier for you. But yeah, this is what you have to interpret, okay, by looking at the question when he's giving about maximum as well as average power. Sometimes, we need to do these kind of work. But yeah, if you just talk about strictly, there is an ambiguity. If it is a DC circuit, you will get different answer. If it is a AC circuit, you'll get different answer. Okay, that's true. I'm accepting it. But that's a question given in the transcript. What can be done? Okay, yeah. Let's see. By considering AC, because I'm taking AC because is given as average power and maximum power, means I'm just treating this one as AC circuit. So in case of AC circuit, voltage and current, pure resistance case, what is voltage? Voltage shape will be, voltage is a sinusoid. Yes, definitely. Lovely sinusoid. And corresponding current is also sinusoid. Then power will be instantaneous power. Let's talk about instantaneous power. Instantaneous power maximum value whenever voltage is maximum and current is maximum, then power is also maximum, right? So P max Pmax is clearly, it is Vmax into Imax. Imax means not a theater IMAX, maximum current I mean. Now we know average power is equal to VI cos phi, VRMS, IRMS cos phi for AC. Cos phi is unity. Cos phi is unity. So because it's a pure resistance case, into 1. Now, would you mind I can write, if I write this VRMS as Vm by root 2 and IRMS also as Im by root 2. So I'm writing this one as Vm Im by root 2 into root 2 is 2. 2 is written. And you know Vm into Im as Pm, not Prime Minister, maximum power by 2. So he's talking about P average is 1/2 of the maximum power. That's what this relation is saying. I'm not saying. Who am I to say that? The relation is saying, I'm just talking about that. Okay. So, what is this, dear? Angular position of conductor? I'm not sure. The question is, I think you're trying to ask a question or something. Question is incomplete. I'm moving to the next question quickly. I think this is easy one. Everybody can answer this question. Okay. Very well asked. Lot of time this question is asked. Yet it is an easy question. Okay. One of the popular questions. Once it is asked in GATE exam also. I mean, similar question is asked in GATE exam also. Okay. So what am I to do? If you're not doing something, just think about it first. Thumbs up. Did you give the thumbs up? I didn't see here. I only see less number. Yeah. Praveen is back. Kalyan is back. Good. Okay. Time's up. Let's see what is asked. In an AC series RLC circuit, okay, the voltage across R and L is 20 volt. Try to construct the diagram quickly first. Voltage across R and L is 20 volt. Voltage across L and C is 9 volt. And voltage across RLC is 15 volts. What is the voltage across C? Wow, it's like a puzzle, right? And we got an answer. Answer is somebody saying it's B. Who is that somebody? Okay. Bala Murugan. Okay. So in an AC series circuit, blah blah blah. Okay, let's quickly draw the circuit. Then things will be a lot more easier for us. Whenever you're dealing with a circuit, quickly draw the circuit. So voltage across R and L is 20 volt. Voltage across L and C is 9 volt. Voltage across RLC is 15 volts. Lovely. Okay. So we know total voltage, if you want to calculate, what is the relation between total voltage with respect to other voltages? Yep. Let's see. We got this voltage is 20. VR plus VL. Okay. So this is VR vector. VL vector is somewhere over here. This is VL, right? And this is VC. A little clumsy it seems to be. Yeah, there are the 3 vectors. Now it is given. Resultant of these two is given. Resultant of these two is given as how much? 20 volts. And now when I add this 20 volts with this VC, you get 15 volts. That's what the total voltage is. Okay. And VL minus VC is also given. This voltage means what? VL minus VC is given as 9 volt. Pretty interesting. So can I say with this, total voltage V is equal to total voltage V is equal to square root of this VR square, because I have this one vector VR square, plus a resultant of VL and VC. A resultant of VL and VC whole square means VL minus VC whole square. That will give me voltage V. Okay, that will give me voltage V, the total voltage. Now you got this number is clear to you. This number is given to you, which is 9 volts, and this number is given to you, which is 15 volts. Now you can find out what is VR. Now you can find out what is VR with this. Now how I got this equation? Simply we know total voltage is equal to sum of, in a series circuit, if I just quickly take a series circuit, in a series circuit what you have? In a series circuit, total voltage V is equal to vector sum of VR plus VL plus VC, right? Now I'm adding this. We know these two are opposite in phase. VL and VC are opposite in phase. So the resultant will be VL minus VC. Okay, then you're adding to this, you're adding this VR. Now you're doing the vector sum. That's why you're getting this. Where is it? No, not this. Question number? Yes, this one. So now you just do this math. You should be getting this VR as, if I'm not wrong, then the answer will be 12 volt. Answer will be how much? 12 volt. Can you try? Oops. What is happening here? My tab is not responding properly. This VR you will get to 12 volts. Now you know VR. You know VR plus VL. VR plus VL is given as 20 volts. VR plus VL is given as 20 volts. VR value is 12 volts. So VL value will be how much? VL is equal to square root of 20 square minus 12 square. Okay, that's what VL. We're doing everything, but it is asked for VC. Okay, we got VR. Now we are getting VL. VL value, if you do this math, VL value will get it as 16 volt. 16 volt. And finally, VC now. VL minus VC is equal to 9 volts. So VC value must be equal to, VL minus VC is equal to 9 volts. So VC value is equal to 7 volts. So I am marking answer as option A. Oops. Seems there is a glitch which you need to figure it out on this tab. I'm moving to the next question. Hope you got an idea. Whenever you get these vectors, you have to deal with the vectors. Careful. Again, I think you guys have watched already the phasor diagram concept videos. If you watch that, I think dealing with the phasor diagrams is a lot more easier, no more difficult at all. Okay, search for it, you'll get it. I'm moving to the next question. This is just a formula based one. Okay, formula based question. You have to know the formula. If you know the formula, you'll get it quickly. Okay, try to recall the formula. What is that formula relation between coefficient of coupling and mutual inductance L1, L2, this formula. K, M, L1, L2. Yeah. If somebody can quickly write the formula, those who are done, try writing it. Let's see. Already we got an answer from Muhammad, as well as Anusha. Nice. Good. Keep it up. Now Sudhir. Very good. Wow. Sudhir has even written the formula also. Nice. Now, guys, you can use that formula. Lovely, Sudhir. Keep it up. Vamshi, nice. Okay. So this is direct based on formula. Coefficient of coupling K is given. Coefficient of coupling K is given as 0.6. L1, L2, self-inductance of the coils are given. L1 is equal to 0.4 and L2 is equal to 2.4. Now the formula what we'll be using, yes, Muhammad has shared a formula, as well as Sudhir has also shared a formula. Use this formula, you'll get it. You're good to go. So M is equal to K into under root L1, L2. Okay. So every value is known to you. Directly plug in the values. You will get the answer as option A. Option A is answer. Let's go to the next question. Just 2 more questions are left. Okay. Easy questions. These will help you to recall your concepts. Okay. Quickly recall the concept with the help of this question, resonance question. I think 1 minute is good enough for this. Okay. Not much time. Naveen, what happened to you, Naveen? You're marking it as something else. Naveen, check it out. Naveen, check it out. Minimum. Muhammad is saying minimum. Okay, time's up. Time's up. Yes, everyone, you're absolutely right. Okay, mostly, except few people. It's okay. Sometimes it happens. In parallel RLC resonance circuit, at resonance current will be, I told you, series resonance is an accepted circuit. Parallel resonance is a rejector circuit. Okay. Previous lecture only I discussed about this, right? If you're not consistently watching, then what can be done? You need to be at least consistent in watching the content, right? Yes. So in case of parallel RLC circuit, you will have Y is equal to G plus J B. B is net susceptance. So this component has become 0 at resonance. So Y is equal to Z. So admittance is minimum under resonance condition for a parallel circuit. If it is a series circuit, impedance will be minimum. So here, as admittance is minimum, impedance is maximum. So current is minimum, hence it is called as a rejector circuit. Okay, just opposite for series circuit. Series and parallel circuits or RLC circuits are dual to each other. Okay, keep this point. A duality concept, if you apply properly duality concept here, even RL circuit and RC circuit, they are dual. Okay, yeah. Let's move to the next question. I think this is purely based on batteries. Okay, I think you'll be able to answer it. It'll take 2 minutes time because it seems to be big question over here. So Take 2 more minutes, 1 more minute, and understand this. Let's see what you got to answer. I think if you want to design electrical vehicles, this could help you, you know. Think properly. Don't be in a hurry. Read the question properly, understand it, and answer it. Good. Some guys are answering nicely. Let's see what others also had to answer. Anusha, Praveen. Capacity. What is a unit of capacity? Tell me. What is a unit of the capacity? Here we're talking about capacity, right? What is the capacity? It is asked for two things. One is a voltage. What is a voltage, and what is the capacity of a battery? So, what do you mean by capacity? What is the unit of capacity? Tell me. Yeah. Yeah, everyone. Type what is the unit of capacity. Very good. Very good. Unit of capacity is, Praveen is saying, ampere hour. Sampath is also saying ampere hour. Very good. Keep it up. Now tell me, Vamshi is also saying ampere hour. Muhammad is also saying ampere hour, or watt hour. Whatever is not usually mentioned. See, I told you, I already given the video also on this, the capacity of a battery. Okay, capacity of a charge. How much is the amount of charge it is storing? Q, coulombs. It's a charge it is storing, right? How much is the charge it is storing? Coulombs. Okay, or else we know I is equal to Q by T. So Q is equal to I into T. So coulombs or ampere second, or maybe ampere hour. Okay, if you extend it to hours, ampere hour. So it is ampere hour. Okay. Now, when I connect batteries in series, small cells are connected in series to form a battery. Its voltage capacity in series, voltage will increase, but the current will be same. So voltage is N times of V. So these two are wrong. It is saying just V. If they are in parallel combination, it is just V. They are in series, just in series. So it is N times of V. Capacity. Is there any change in the current? No change in the current. Current is same. So time is anyways, hour is fixed, right? So ampere hour is not going to change. A. You connect to the same batteries in parallel, then ampere hour will change. Voltage will not change. Okay. So you connect both series parallel combination. That's why whenever you're designing a battery for your electrical vehicle, if you want to design your own vehicle, then you can do these kind of things. I think we have a batteries over here. Yeah, we have a batteries which we use for our research. Okay, these batteries are good enough. These batteries, whatever we have. Yeah, these are not regular batteries, of course. Okay, regular, not AA batteries. The pack of these batteries, you'll be packing these batteries and you can make a stack. Yeah, milliampere hour, or That's just milli and all these things are numbers. Okay, that's it. That's it. We're done. We're done with Transco 2015 questions. Very good. This time you guys have rocked it. Okay. You guys have really rocked it. Keep it up. So let's end up the discussion. If you have any questions on this topic, on this lecture, I would like to take it. Otherwise, bye bye. Catch up in the next session. Anything to ask? Anything to ask? Okay. Well, we got a question. I think. Allowed Sekhar's explanation. To my college, I'll stick to. Okay. Okay. Thank you. Thank you, dear. Thank you, Praveen. Okay, guys. That's end of lecture. Catch you up in the next session. Okay. Bye bye.